Okay, hello everyone. Today we're going to be talking about even more numerical systems. Even more because I've already done videos on the binary system and the hexadecimal system. But I'd like to continue this, and today we're going to be introducing the ternary system, the quaternary system, the octal system, and some more. To understand these systems, we need to properly understand how our own system works. The one from 1 to 9, which then starts over at 10. We need to understand the proper mathematical definitions behind the digits. Hence, here are these calculations. So we have the number 1, and the number 1 is a ones digit, and hence it will be multiplied with 10 to the power of 0. And as a mathematical rule, something to the power of 0 is always 1. So in the end, it would be 1 times 1 is 1. Then next up we have the number 10. The 1 here is in the second digit place. Hence, we will have to multiply it with 10 times 1. If it were to be in the third digit place, we'd have to multiply it with 10 to the power of 2, and so on. But now it's in the second one, so we have to multiply it with 10 times 1. 1 times 10 plus 0 equals 10. And then finally, we have 32. I just made this up as an example. 3 is in the second place, in the second digit place. So 3 will be multiplied with 10 to the power of 1, and then added with 2 times 10 to the power of 0. 3 times 10 plus 2 times 1, which will then go over to 3 times 10 plus 2. 30 plus 2 is 32. Great, now we have properly understood the principle behind our numerical system. Let's start off with the ternary system. The ternary system is the numerical system with one more option than the binary system. I'll leave a link to the binary system in the top right corner and in the description. Here, instead of 10, the one we have here will be multiplied with 3 to the power of 0, hence ternary system. And 1 times 3 to the power of 0 equals 1, because 3 to the power of 0 is always 1, 1 times 1 equals 1. Then we have 10. 10 is nothing else than 1 times 3 to the power of 1. You can recognize the color under the term which represents the digit place. For example, the 1 here and the 10 is in the second digit place, so it will be 1 times 3 to the power of 1 plus 0 times 3 to the power of 0, which adds up to 1 times 3 plus 0. 3 plus 0 is 3. As the last example for the ternary system, I picked the number 22. In 22 we have a 2 on both the first digit place and the second. So we'll have to multiply 2 with the green underline times 3 to the power of 0 plus 2 times 3 to the power of 1, which equals 8. 2 times 3 is 6, plus 2 is 8. Moving on to the quaternary system. The quaternary system follows the same principle as the binary and ternary system, and the one we have here will be multiplied with 4 instead of 3 or 2, as in a binary and ternary system, to the power of 0. 1 times 4 to the power of 0 equals 1. Then for the tens example, the 1 here is in the tens digit, in the second digit, so we'll have to multiply this with 4 to the power of 1, so 1 times 4, and add it with the ones digit, which is 0 in this case. So 0 times 4 to the power of 0. 1 times 0 plus 0 equals 4. And for the final example, I picked 31. This is quite easy. The second digit, the tenth digit, will be multiplied with 4 to the power of 1, 3 times 4 to the power of 1, and the ones digit, 1 in this case, will be multiplied with 1 times 4 to the power of 0. 3 times 4 plus 1 times 1. 12 plus 1 equals 13. And trust me, this is the last boring math example, but last but not least, we have the octal system. The octal system has the exact same principle as the ternary, binary, quaternary, and so on principle, and even the decimal principle. Just in this case, the factor will be 8. So once again, as always, if you write down 1 at the octal system, it will be 1 times 8 to the power of 0. 1 times 1 is 1. For the tens, the tens digit times 8 plus 8 to the power of 1. 1 times 8 plus 0 times 8 to the power of 0. So 1 times 8 plus 0. 8 plus 0 equals 8. And then for the final example, there's 27. 2 in the 10th digit place, the second digit with the red underline, will be multiplied with 8 to the power of 1. And the 7 with the green underline, which represents the 1st digit, will be multiplied with 8 to the power of 0. 2 times 8 plus 7 times 1. 2 times 8 equals 16. 16 plus 7 equals 23. Okay, so now we have met numerical systems with less digits than the decimal system. For example, the octal system doesn't know the digit 9 or the digit 8. It just knows the 1 to 7. What about numerical systems that have more digits than our decimal systems though? You might think now that it invents new digits, which would be quite interesting to be honest, but sadly it doesn't. Not in our scenario in which we use Arabic numbers though. These are all Arabic numbers. Arabic numbers are the numbers we use every day. Here's an example. This is the hexadecimal system, to which I made yet another video. Link is in the description or up here. They just add the Latin alphabet to it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 as usual, and because the 10 doesn't have its own digit, it gets replaced with the Latin alphabet. A stands for 10, B for 11, C for 12, D for 13, E for 14, F for 15, and the list would go on if the hexadecimal system were to be larger, which it isn't. But there are larger, much larger numerical systems. For example, this is a sexagesimal system, which has Babylonic origins. This is a system with the base of 60. As a comparison, our decimal system that we use every day has a base of 10, which means it will repeat every 10 digits. Like 10 in our system doesn't have its own digit. In this case, 60 is the first one that doesn't have its own digit. I'll leave a link in the description to a Wikipedia article where you can take a look at all the numerical systems that there are. I wish you all a great day. And that's it for the video. If you want to see more every Saturday, please consider subscribing this channel for free. It would mean a lot to me and surely help me out. You can also join the Discord. Link is in the description. Have a good day.